So now it's time. So let's start. So hello everyone and welcome to today's webinar, Machine Learning in Reserving Introduction and Recent Developments, presented by the Machine Learning in Reserving Working Party of the Institute and Faculty of Actuaries. This webinar is sponsored by the IAA Data Analytics Virtual Forum and the General Insurance Forum. My name is Ryutaro Yamada, and I'm delighted to be your host on behalf of the two forums. I am the Group Chief Actuary of MS and AD Group, Chair of the General Insurance Forum, and a member of the Data Analytics Virtual Forum. We are pleased to have Jackie Poon leading our presentation. Jackie is a member of the Machine Learning in Reserving Working Party. Based in Sydney, he is head of Actuarial and Analytics at NIV Health Funds Pty Limited, a subsidiary of NIV Holdings Limited. He serves on the Health Practice Committee of the Institute of Actuaries of Australia and previously chaired the Young Data and AI Working Group of the Institute Actuaries of Australia. Before we begin, a few housekeeping items. All participants have been muted and the verbal Q&A function is disabled. To submit a question at any time, please click on the Q&A icon at the bottom of your Zoom window. We will collect all your questions and address them during the Q&A section at the end of the presentation. This webinar is being recorded. A video of today's session, along with the slide deck, will be posted on the IA website under Publications Papers within the next day or so. You can find it at www.actuaries.org in the Papers section. Next, please note the disclaimer on the slide 3. Any views or opinions expressed here are solely those of the presentators and do not necessarily reflect the official position of the IAA. While we have made every effort to ensure accuracy, neither the IAA nor the presenters can accept liability for any reliance on this material. With that, I will hand you over to Jackie, who will introduce the topic and kick off our dive into machine learning in reserving. Jackie, over to you.
Thank you, Ryu. It's a privilege to be here and represent the IFOA Machine Learning in Reserving Working Party. Our working party has volunteers from all around the world. So although it's based in the IFOA, I am based in Sydney, and we have members from a number of different countries. And we're all working together to help actuaries gain machine learning skills. We've got a foundations page with resources to help you build your knowledge. And our principle is to provide code and explanations together with cutting edge techniques and research. We'd like you to try this at home, or to be more precise, probably at work as well, to see how it goes for you. And for neural networks specifically, I'll explain why we've chosen to focus more on neural networks. We are trying to create frameworks and other tutorials to make neural networks accessible to all the actuaries around the world who are interested in this topic. And if there's one message that we'd like people to take away from today's session, we want companies to take and apply to their own data and see how the models perform for you. We'd be interested in your feedback and your findings. But of course, with that important disclaimer from earlier in mind around warranties and not taking any liability for any consequences that may occur. That's still on you. Your actuarial judgment still applies. So then I think let's start by addressing the elephant in the room. When I speak with some actuaries in the industry, and I mention my keen interest in machine learning and claims reserving, we do often get reactions of, oh no, we've used triangle methods for the last 600 accident periods, and we're going to use the triangle methods for the next 600 accident periods more. So the question must be asked, why should we consider machine learning in claims reserving? And I just draw out a few points. The first is that we do work in a big data world these days. Many insurers have access to a wealth of information, and yet for a lot of organizations, we're still working with the summarized triangle-based methods when we have this gold mine that has potential to help us. And if we were to use that additional information, and if the results show it is a more predictive model, then wouldn't that be a case to use that model? Another consideration would be that with machine learning methods and individual granular methods, we can get to a level of detail that we're not able to achieve with traditional actuarial reserving approaches. And this can support real business value to several areas of the organization. The first would be pricing and performance, where you could potentially get a better estimate of the claims or ultimate claims, the performance when drilling down into segments. If you were to take a simplistic chain ladder-based approach, your development factors could lead to very volatile results when applied to smaller segments with a small number of claims in those recent development periods. Another angle that where these granular models could deliver values would be claims analytics. We've seen some actuaries go into the claims analytics space, perhaps not as much as they could be. But if we were to drill into the individual claims and make predictions to support things like fraud modeling and cost containment, or perhaps to look at claims in different ways to support things like operational aspects of claims management, then having the granular model that predicts at the claim level or at the policy level could allow us to unlock value that we would not otherwise have. And often there is a bit of a reluctance with machine learning in this application because of that fear that it's going to be black box. You're not going to be able to know whether what works or what exactly it is doing. But there are a number of techniques to peer inside the so-called black box. Techniques such as SHAP, LIME, partial dependency plots, they can help you understand what the model is doing and also how it is responding to different features in the data. And the point to draw out is that having machine learning techniques may complement existing methods. You don't have to scrap your existing triangles, and it could potentially act as an early warning system. If you've worked as an actuary for long enough, you'll probably have seen portfolios gone bad in your organization. And if not portfolios, then perhaps segments going bad. And having a traditional actuarial model may lead you into missing the trend until quite some time has passed. Perhaps having a more granular individual machine learning model could help you detect these changes in the trend. So as an introductory reference, I'd refer to one of the articles in our blog. This is a practical introduction to using neural networks in reserving on individual claims data. Gives you a bit of an overview of what we're about, but we'll also share an overview of what we're about today. Today's session will be more wide and not deep. We'll be explaining how to learn about learn about machine learning, learn about how to apply machine learning in reserving, and also learn about the situations where these techniques may be useful to you But rather than going into a detail level for each of these topics, we'll run out of time. We'll give you references for you to further develop your understanding depending on your own interests. And in the working party, we've had a particular focus area on neural networks. And I think it's worthwhile to explain why we've taken that focus. The first would be that actuaries are quite familiar with GLMs, especially those who work in pricing, and neural networks are in many ways a generalization of GLMs. Residual networks are similar to GLMs with additional hidden layers that can be optionally skipped. And neural networks have also been used in a number of state-of-the-art applications. We've seen it used in image recognition. If you've ever tried to use image recognition on your phone, then these are all neural network-based algorithms. They've been used in text. Everyone's heard of ChatGPT by now, unless you've been living under a rock. And for things like audio data, things like Whisper utilize neural networks to turn voice to text in a very clever way. Transformers have proven to be quite powerful for sequence data. Entity embeddings can effectively model categorical variables. And the algorithms can also output probability distributions if you apply mixture density networks. So there's a lot of flexibility with these sorts of neural network structures, and we're curious whether we can find a suitable model to apply to claims reserving problems. Of course, it's not all roses, and as actuaries, we should be always cognizant of the advantages and disadvantages of different model structures. So some caveats to disclose here would be that sometimes simpler models may be more effective, as we should always consider. With tabular only data, gradient boosting decision trees is alongside GLMs, the gold standard in pricing. And random initialization is what you would typically do for a neural network fitting, and it does lead to variance in model prediction, so we need to be cognizant of that. And finally, for the problem at hand is the complexity you're adding into your modeling process, delivering additional value compared to more simpler models. But first, there is a question about learning about machine learning. It's perhaps the group of people joining this call are more predisposed to having already developed some of these skills, but perhaps some of you are at the start of your journey in terms of coding in things like R and Python. So I wanted to just take a few minutes, and for those who are more experienced practitioners, please bear with us as we talk about this. But how do you establish a baseline level of skills for your machine learning? So my recommendation, if you want to learn Python and learn it quickly, would be to follow this sort of sketch of a syllabus. You can start off with Visual Studio Code. It's a code editor by Microsoft and it's free. They have a YouTube tutorial. And there's also a book called Automate the Boring Stuff. And that's, again, a free resource. You can follow the first 11 chapters is what I would recommend. After that, it starts to get into topics that are perhaps not so relevant to what we're trying to achieve. I've also included, to fill in the gaps, a short tutorial on things like list comprehensions. And for those who have worked with SQL, go translate some SQL to Python pandas logic. And that should allow you to wrangle the data in Python as well as you can in SQL pretty well. Another thing for getting up and running with coding in Python quickly is that we are things are as user-friendly as they've ever been. When I first started on this journey with learning Python and R, there wasn't very many good resources out there. The code editors were less user-friendly. And finally, we didn't have AI. And I would recommend trying out Claude 4.0 by Anthropic and Google Gemini in Google AI Studio. As long as you're very specific about what you're looking for and you define the format of your input data and the format of your output data, it can actually generate code that is often not perfect, but it's like 80% there. One needs to be very careful about the 20% that it isn't there for, and that's why still need to learn your Python, and you still need to make sure that you've got the tests and diagnostics on the outputs. But you can get up and running with a piece of code really quickly, thanks to these large language models that are now freely available. And as an extra incentive, I feel, for actuaries to learn these sorts of things, I just want to add that even if you don't end up doing machine learning for your reserving tasks, learning Python can help you automate your processes. And within my team, my team has been able to automate some of their actuarial data pipelines with the help of Python, and it's a big game changer for us. So even if you don't end up applying this for reserving, I think it's worthwhile for you to pick this up. And then once you've learned the basics of the programming language, where do you go from there in order to develop machine learning models if you want to build them from scratch? So I, along with many volunteers from the Young Data and AI Working Group and the Data Science and AI Practice Committee, we've developed a cookbook, or what we call a cookbook. And we're not actually cooking your dishes for eating. We're cooking up these pieces of actuarial or data science analysis. And we've got a number of tutorials there that we're once again similar to the principles in the machine learning for reserving working party. We've got the code available, the ideas are there, you can download it and you can run it and you can borrow from it to build up your own projects. And if you'd like to just test your skills in that area, I have an example exercise for you. So these slides will be available after the talk together with all the links. If you are running through this later, I would recommend doing this exercise to build your own exploratory data analysis and web app and regression model on this data set as a sort of capstone project for yourself. And if you've gotten that far, the next question would be, how would we go about applying machine learning techniques in claims reserving? We're finally getting to the main ideas in our approach. So in the machine learning for reserving working party, we've explored a number of different approaches. And if we were to condense it, this is how I would summarize the basic ideas in the things we're looking at. The first, as a preface, I would say that you should check out our blog. Again, we do have learning resources for beginners with the foundations page. And for those experienced practitioners who are just curious about specifically how do you apply machine learning in reserving, there is some latest research that you can reference, and we do provide all the code and explanations. So check this out. It's designed for you to download it and run it on your own data. And then if you've got any issues, please report it back to our working party. We also have it in the format of a book. A lot of it is done in R, but there's a lot of good content there covering things from the very basics to more advanced models and new or recent literature. One of the things we do in our working party is use simulated data. And the reason for using the simulated data is simply a practical one. Unfortunately, there's not a lot of real-world data sets to test and benchmark our various techniques that we want to try. And so the SPLICE paper is a simulation package, and it allows you to create these realistic synthetic claims data scenarios. But I will say that just because we're testing on synthetic data doesn't mean that the tests are in any way inadequate. One of the key advantages of using synthetic data is that you can actually introduce specific challenges to test how well models respond. Similar to the fellowship exams, you can create scenarios where you show up to work and mysteriously something has gone horribly wrong with your claims data for this month, but your year-end results are due and you need to prepare a scenario for your CFO tomorrow, something along those lines. With this synthetic data, you can introduce stresses into your claim scenarios, and we can then benchmark how our different models respond to those scenarios. So that is pretty handy. And the SPLICE package extends on previous work with the synthetic package. And here we've got introducing case estimates. So we're getting more and more interesting with our claims data to build our models on. And then once we get through the data phase, okay, what do we do with the models? I'd like to, for those who are starting from a more traditional actuarial lens, I'd like to just introduce this idea that firstly, triangles are tables, and the chain ladder is in fact a GLM. And the concept is this. If you take your data and you one-hot encode your occurrence and development period, and you fit a log link over disperse Poisson or some other like log link GLM, then your incremental payments is a fit on occurrence period and development period. And that is mathematically equivalent to a chain ladder model. And with that in mind, that means that your data is looking like this. You've got your accident period, you've got development period, you've got your claims paid. I would ask the question, well, what if instead of having it in a summarized format, you had this in an individual format? What if these were individual claims records or something along those lines? That's how you would go about expanding your chain ladder into something a bit more granular and a bit more detailed. And we've tested a number of ideas in this vein. So as the simplest example, we've got a blog article where we take that GLM, still in that triangle format, and we swap out GBMs, neural networks, or lasso GLMs. There's literature on how GLMs are a special case of a neural network in a set of PowerPoint presentations by Mario Wolfrich that I would just reference as well for those who want to understand that a bit better or take another look at that. And within our blog, we also have an example article that I put together where we take that chain ladder and we keep on generalizing it. We generalize it to an individual model, we generalize it to a probabilistic model with neural networks. And we just build up from the chain ladder into something quite complex and sophisticated. And for those who are thinking that maybe, well, chain ladders, great, but I'm using payments per claim incurred. Well, is there something along those lines? Uh, in a paper I wrote about 6 years ago, I looked at similar ideas with policies and claim counts and claim amounts data. I've just included that more as a side note to highlight that neural networks, they're flexible and you can put in different functionality in there to reflect certain model forms that you want to achieve. And not only are they flexible for tabular-based data, they could be applied to sequence-based data. And with claims histories, they are effectively sequence information. We have your new claims being reported, then case estimates may change, payments may be made, and finally the claim is settled. And so, especially more recently, but even before that, we've been exploring things like the transformers, the GRUs, and LSTMs, the sequence-based neural network model forms, to see how they perform in predicting the ultimate cost of a claim. So I'm really excited by this research and be interested to see how it develops. Our chair of the working party, she's created a series of free models for those who are interested to try neural networks out. And in her article series, she explains how to implement a neural network and step you through step by step diagnostics, because just because it's a quote unquote black box model doesn't mean that you shouldn't look at diagnostics to see what it's doing and how effective it is. And finally, model tuning. How do you tune those hyperparameters? What happens when you tune those hyperparameters? What looks like they'll be the most important ones? There's an article that talks you through some of the key points there. And I would be remiss to not give a mention to generative AI, given it is the topic du jour at the moment. I would just say that it complements, but it doesn't necessarily overlap that much with the activities of the machine learning in reserving working parties. I will observe that in the practical application, claims diaries may often include unstructured data, so things like claims notes, and so forth. And you can apply both traditional techniques with natural language programming, as well as Gen AI techniques to read the text and pick out and engineer some features that you then feed into your model. So in the cookbook, we've created an example that just does just that. It's just looking at bag of words and embeddings to identify keywords that drive particular outcomes. And you can apply the same principle to claims to see what drives claims costs. And we've also added a new cookbook article where we talk about taking freeform text and using the LLM to just read a column and fill into a structured data field. Either way, what you end up with is these input features that you then put into your machine learning algorithm. And the machine learning techniques are what the working party is more focused on. But if you're implementing this in practice and you're finding that, hey, I'd like to know if this claim is of this type or that type, but all I've got is a freeform text field. This looks too hard. The answer is no. We can work with this. So yeah, that's something that we can apply to support our machine learning efforts. And so we then get into a few example scenarios. And the reason why I wanted to share these scenarios was to just prompt some thinking about this application of machine learning in claims reserving. I guess a impediment to some actuaries from applying it at their workplace would be a thought of, hey, this looks fun, but hold on, I'm trying to solve a real problem at work here. Is this machine learning method really going to help me? And so I want to bring up a few examples of scenarios where, yes, taking a look at things from a different approach may potentially drive a better outcome from a modeling perspective. And the first would be things like mix effects changes. So this would be an example where the portfolio mix has shifted over time. And to complicate matters further, people are speculating that actually that mix shift is affecting the way that the claims are developing. The traditional way to do this might be to just apply your pricing model and then apply something like a BF based on the pricing prior. So the mix shift is factored into the prior. But if you feel that maybe the claims are developing at different rates because of your change in mix, and you're not able to easily split out the change in development through some identification of a factor, then you may need something that interacts between your pricing model and your reserving model. So looking at both your pricing features as well as the speed of development of those features. So that would be one where a more complex model may be warranted. Another example where things may warrant looking at machine learning methods would be one where, for example, paid is unusually high, but maybe faster processing is contributing to it. And there's not enough in your triangles to prove that there is a new development trend, but then you might have some other corroborating metrics. What would you do in practice? Well, some angles that are more on traditional side could be to look at things like the forecast, but you could also factor those operational metrics into your model prediction and build a model based on that. That could be something as simple as a GLM, but maybe ML models may be appropriate for this use case. Another example would be case estimation. In the traditional way of working, we would rely on claims assessors to assess the probable ultimate cost and assign that to a case reserve. And the claims team would typically have some kind of claims manual that then provides a set of guidelines on setting that probable ultimate cost. So in theory, it should be consistent over time. However, sometimes the ideal does not actually flow through into what occurs. And what if you don't trust the case reserves? Could you set your own case reserves using machine learning and AI methods? So with some of the machine learning techniques that we're exploring with the sequence-based models, they're used to predict the ultimate cost of a single claims. So in an ideal world, they may also be sufficient to set your own case estimates. You would then not have to rely on the case estimates from the claims team, or you would consider both the case estimates and your own data for a more accurate prediction. You may also use that as a diagnostic to just check whether there seems to be some changes in the claims processes over time. So those were some examples where if something unusual happens in your data when you're doing your claims reserving, you may actually have a business case for applying these machine learning methods. It's not just for your fun and enjoyment. There might actually be a real value application for these. And so now we move on to our current focus and some of our own research in the working party. And if you want to get up to speed with research, there was an article that we put up on our blog, which goes up to 2021. It looks at a brief history of papers if you're more academically inclined. We also have a working party journal club where we read different papers and then discuss them, similar to a book club over a nice cup of coffee and sitting in front of the metaphorical fireplace, but mostly over Teams to discuss these papers and what we think about them. So for those academically focused, we have interesting things happening in the working party. But that's not the only area of focus for the working party. We have volunteers creating and sharing the development resources, such as the blog. We've been looking into sequence-based models and trying to create simple examples that work well. And looking at diagnostics, we're well aware of that concern around black box being concerns around transparency with black box models. So we want to develop out what will be the best practice looks like for diagnostics for these models. And of course, keeping up to date with literature. Some of our members have been replicating some papers that they've been interested in, and there's an interest in being able to compare these models and see how well they would perform in various datasets in various situations. And we're all very excited about the potential for these techniques. And so we'll conclude with a call to action. So the Machine Learning in Reserving Working Party is a volunteer group, and a lot of the activity that takes place often happens in spare time. And so what we're looking for would be support from businesses to increase our speed of progress and development in this exciting area. We're always looking for more people to help, and we have more ideas than we have capacity. So a question for the people on this call would be, what can you do next if this is an area that you're excited about as much as I am? So this concludes the main session, but we have some time for Q&A. I'll pass back to Ryu.
Thank you, Jackie, for your comprehensive and many valuable insights. So let's move on to the Q&A session. First of all, we got some requests that about that slides deck. As I said, a video of today's session along with the slide deck will be posted on the IA website under publications papers within the next day or so. So please go to the IAA website. And so we have 14 questions. So, okay, so the first one, the question about machine learning being black box. How about using models which are explainable? For instance, random forest. In banking and insurance industry, it's important to understand the decision taken by the model. So curious about using classical machine learning algorithms to solve an optimized problem in hand. So Jackie?
Sure. I think that models need to be appropriate for the business purpose that we're applying to. So there might be cases where a simpler lasso or decision tree based ML model may be the best approach for a given problem. But I would again highlight that even with the more complicated model forms, there could be ways to diagnose and decipher what that model is looking at through the partial dependence and SHAP diagnostics and be able to peek inside the black box. You would need to look at your particular application and see if those diagnostics are sufficient to explain to your key stakeholders and justify the use of that model.
Okay, so the next question, how well these machine learning models are performing on real data sets, usually because in real life data results are not good. Can you list possible errors someone might do when doing with real data?
I think it's very hard to say without talking about each real world problem. You would need to, firstly, I think for real world data, step one, you need to have good quality data and you need to have reconciled it as you would with any data set that you'll be using for reserving. If the model results are not good, then there's a number of things that could be going wrong. One would be it's underfitting the dataset, another could be it's overfitting the dataset. Things like diagnostics would be where I would explore to figure out if it's not good, like why is it not good? Is it underpredicting, overpredicting? Is it underpredicting for certain features? Is it missing certain elements of what you think should be happening? And use the diagnostics to then make adjustments and hopefully it'll work good after that.
Okay. So the next question, how well these machine learning models are performing on real data sets? Usually in real life data sets, a lot of negative values in the triangle. How are A vs E with NN models? Are they really good?
I think once again, you need to test it on your own data set and see how well it performs against other approaches. Negative values aren't necessarily a problem. It's possible to have claims go back down in incurred and you can select different model structures to accommodate that. Obviously, if you're using log link, then you can't log negative values, but you just need to figure out how to put those values in a way that's sensible. Even though there might be negative values in a transactional level, in theory, your claim value should all be bigger than 0, for example, and then that would allow you to fit it into a log link.
Okay. So another question, do these machine models reduce the gap between the ultimate paid and ultimate incurred? Usually in a perfect ideal world, they should almost be equal, but it never happens.
Oh, I'm assuming that Uday, you're referring to a projection based on the paid versus a projection based on your incurred. So like a chain ladder paid versus chain ladder incurred. In theory, if you had the ideal machine learning model, it would be a model that uses both the paid and the case information and then just makes one prediction. So that would lead to your ideal world. However, obviously, if you exclude some of the information, like if you don't feed in the case estimates, you're going to get a different prediction because you've got a different model. I hope that answers the
Okay.
question.
Another one. I tried the NN model and some lasso techniques with SPLICE.
I think that might have been
It's
the answer
good.
for the question
Yeah.
we had last time.
Oh, okay. So do these sorry. It's just when running a lasso GLM, it may kick out certain almost random development quarters or incurred quarters. What do you make of this? Would you still always keep all the development quarter and incurred quota independent variables?
I think that with Lasso, your model form is still simple enough that you can apply human judgment to the selections because it is still a chain ladder. And so if you're going down that route, you would probably still want to think about what you do with these based on your best actuarial judgment rather than relying simply on the model, unless for some reason you're batch applying this to a large data set.
Okay. So based on your implementation on machine learning in reserving, were there improvements in accuracy of your reserving? For example, better AVES?
That's a difficult question to answer because, for example, in our blog, we tested different techniques on a SPLICE dataset. And in that SPLICE dataset, those machine learning methods were able to outperform the traditional chain ladder approach. But there's a couple of caveats to that result. The first is that in practice, one would not just simply apply a naive chain ladder model and just adopt all the factors as is. Actuarial judgment would be applied to that. And in the same way, even if you apply a machine learning model, you'd apply actuarial judgment to those results as well. Secondly, that is a synthetic data set, and the data set that you work with personally may be different to the one that we have tested those models on. So that's where that call to action comes in. We are looking for people to try it on their real world data set and see how it performs. But in theory, on those SPLICE dataset with all those caveats, there were improvements in the accuracy of observing. It's just that those caveats are significant, so we should be aware of that.
Okay. How is inflation handled in machine learning techniques, especially if it used for prediction? Do historical data has to be made comparable to current value of money before application, or do machine learning techniques implicitly, sorry, I lost it, implicitly right for the inflation in historical data?
That's a really interesting question because it's one of the things that I've been personally giving a fair bit of thought to. I would say that it is often helpful to normalize your data to current value of money, even if you are feeding it into a model, simply because that will help the model. However, how each ML method handles inflation depends on the ML technique itself. If you have built in a specific factor into your model, then it will go and predict some kind of inflation or superimposed inflation number. However, for some, you have to consider how that machine learning technique will interact with inflation. An example of that would be something like a gradient boosting type model. If you apply a decision tree based model onto your data, of which gradient boosting is an example, then decision trees cut data into steps. They implement step changes. And a caveat to a step change based representation of your world is that your inflation is effectively flat at the end because it's a step change and then there's no more steps after that by default. But you can overcome this by making enhancements to the ML method. For example, I've got an example where we've stacked a ARIMA on top of the partial dependence of the gradient boosting method, and then that will allow it to roll forward with some kind of future inflation view. But the short answer to your question would be that don't assume that it comes out of the box, and I think it needs to be something that should be considered when you do apply that ML approach.
Okay, so we have 10 more questions remaining from the audience. So the next one is problem with machine learning and reserving is that reserving is a highly regulated area. Besides SHAPS and other explainability measures, how do we convince management and regulators that this is a suitable method for reserving?
Sure. So, as we're speaking to the International Actuaries Association, I imagine that we're working in a number of different regulatory environments. So, one needs to consider the regulatory standards in which we're operating in. In Australia, we have regulations that specify that we need to predict a expected value of the liability as well as a risk margin, but the standards do not go into a lot of detail. Well, it goes into some detail as to what needs to be included in those expected values and into those risk margins, but it doesn't necessarily specify a method that it has to be generated by. So then the question would be, well, how do you convince the regulator that this is an appropriate prediction? There's a few pieces there to unpack. One could apply the machine learning method and then see what that would translate to if you were to make equivalent selections in a traditional method, and then show that those selections are still a reasonable representation of reality. One could put together a documentation on the diagnostics and show that this method has been really effective in terms of predicting the accuracy of the reserves, even more so than the traditional approaches if you were to backtest that over a period of time. That could give some weight to the evidence. The regulators might be interested to know what happens if the assumptions are stressed in some way, whether the model can react to that appropriately. To that earlier question, if inflation were to tick up, does the model respond appropriately to that? And talking through all of the issues that could occur. A similar approach could be taken for management. Management do tend to be a bit more enthusiastic around things involving AI, especially in the current environment where there's a lot of excitement around AI and machine learning. But the key thing would be to first convince ourselves. And in doing so, we probably would be performing a lot of diagnostic checks before we implemented those. So we can use a similar suite of evidence for management and regulators. I think another thing to call out is that I hope that people from regulators are also dialing into this call too, and that we would be interested in your thoughts as to what would convince you as well. So please reach out to the group if you work for a regulator.
Okay. What do you think about the predictory tool for machine learning triangle modeling?
I'm sorry, I'm not familiar with that tool myself, so
Okay.
the answer to
Okay.
that.
How do you how to do join this volunteer group?
Sure. I'd reach out to the chair of the group, Sarah McDonald, and if you're not able to find her contact on LinkedIn, then feel free to message me on LinkedIn, and I'll pass on your interest to the chair.
Okay. So how about setting up a hackathon to solicit new ideas?
That could be interesting. We'll share that with the chair of the group. One catch is that I guess we're presenting to an international audience, and the interest in machine learning is from actuaries all around the world. A practical challenge with a hackathon may be to how do we get everyone around the world together for a hackathon? But if you're keen, please contact us, and maybe it doesn't necessarily be through a hackathon, but we can get you involved in participating in a number of exciting areas of our work and research.
Okay. What have been the results and reliability of applying machine learning techniques to long tail lines of business, like liability insurance so far?
I don't because my background is in short tail, I don't have any anecdotes to share myself. But I would foresee that if we were to find value in those long tail liability classes, part of that value would be in what I described around the case estimates and predicting the ultimate claims costs of individual cases more accurately. This is due to the likelihood of large claims distorting the final answer in that portfolio. Being able to read the claims information and predict the individual claims more accurately could deliver some value there.
Okay. How widespread the use of neural networks in claims reserving?
Currently, not as like it's not very widely used, and that's the reason why our working party is working towards creating these educational resources so that everyone can try them a lot more easier, and why we're testing these approaches for claims reserving.
Okay. In the past, I learned some of the topics discussed in the session, but I can't recollect. Maybe, sorry, this, okay. Because the interest of time, maybe a few more questions, but we still have more than 10. So, okay. How would you use machine learning when referring claims experience to an industry standard table rather than from first principles?
Apologies, could you repeat that question?
Okay, how would you use machine learning when referring claims experience to an industry standard table rather than from first principles?
Hmm. I'm guessing that person would operate in a environment where there's certain industry or regulatory requirements, but being not working in such a jurisdiction, I'm not really familiar with that. So
Okay.
apologies, can't answer that one. And also, I'm noticing that there has been some questions that have been accidentally marked as answered. So apologies for those incorrectly marked questions as well. We will get a list of the questions coming through to us after the call, and I can respond to some of the individual questions through offline as
Yeah.
well.
So maybe, yeah, we are now reached the end of our Q&A time. So thank you to Jackie for sharing your expertise, and a big thank you to everyone who sent in questions. If we didn't get to your question during the session, please feel free to email technical.activities@actuaries.org, which is shown on the last page of the slides, and we will make sure you receive a response. Thank you for joining us. We look forward to seeing you at the future IA webinars and continuing the conversation around machine learning in reserving. Have a great day or evening or night. Thank you.